All right, welcome back to the drive-thru, sponsored by the deli. Hungry? Stop by the deli. Make yourself a sandwich, some salami on it, and maybe some mayonnaise on wheat. All right, this is section 1.3. We're pretty much just taking you through an old PowerPoint turned slides here. This is pretty much just getting used to these three words: collinearity, betweenness, and assumptions. Okay, so points are said to be collinear if they lie on the same line. So here we would say that A, B, and C are collinear. Points that do not lie on the same line are said to be non-collinear. That's how you say that word. So here, points Q, R, and S are non-collinear. That's it. So, take a look. Name some collinear points. There's a lot of them. You just got to make sure you keep them in the same group. So A, M, O, P, and X would be collinear. X, N, and B would be collinear. We'll go back to that one real quick. X, N, and B are collinear. A, L, and B, collinear. O, and L are collinear. Some non-collinear points would be any points that form an angle or do not intersect. So A, M, and N are not collinear. Even though A and M are collinear, A, M, and N are not. I think you guys probably understand that. Okay, so if lines are collinear, then if points are collinear, then one point must be between the other. Okay? And the definition of betweenness is an important kind of foundation for geometry because it helps us add segments. Okay, so here, point A would be between point B and D. What that means is that BA plus AD equals BD. And that'll be kind of a foundation in this class. Okay, this is a theorem that comes up all year, and it makes total sense, but so I probably have to explain it to you. So for any 3 points, they can either be collinear, non-collinear. Okay, so here you see 3 collinear points. Here you see 3 non-collinear points. The triangle inequality theorem is this: the sum of the lengths of any 2 sides of a triangle is always greater than the length of the third side. So here, let's think about that. Let's say we had a big side here that was 10 units, and it's the biggest side of this triangle that I choose. And then let's say we have a medium side that is 7 units, and then a small side that is 2 units. That one would probably be a little shorter, and there we go. Okay, here's what I want you to think about. If this blue and red segment were like blowing in the wind, they would be making circles, just blowing around in circles. Let's say there was a hinge there. So imagine that the blue and red segments were blowing around in circles. Well, since 7 and 2 is less than 10, since 7 plus 2 is 10, there's no way a triangle would be formed. This segment would go to here, this segment would go to here, and there'd be 1 unit in between them. Now you should understand the triangle inequality theorem that says that the sum of any 2 sides of a triangle must be bigger than the third side. That's a pretty important one. Here, the 2 smaller sides, 10 plus 14, or 24, that's bigger than 16. That will work. Okay. These are the things that we are allowed to assume in geometry. Okay, so if you see a line, then it's a straight line. If you see a line with 3 points on it, you can consider that a straight angle. If there are points on a line, you can consider them collinear. If there are points on a line, you should be able to assume which one is between the other. And that's kind of similar to that fourth assumption. Here are things that you should not assume in this class. Do not assume that things are right angles, even if they look like right angles. Don't assume that things are congruent, whether they are segments or angles. And don't assume that one segment is bigger than another segment just because it looks bigger. You should not assume that lines are parallel. And this will be a good little way to finish it if you want to practice that. Otherwise, you can get working on your homework. Boom!